So I think Carl touched on gas per second being a metric that sometimes poses problems when we're actually looking at real bottlenecks. Where is gas kind of coming short today? What are some bottlenecks that we're seeing that we want to focus on? Maybe Chab, I'll have you start things off.
Thank you. Thanks for having me. So for me, first of all, gas is, as we have seen, is kind of a strange metric. Besides the fact that it's quite virtual, it's also an abstraction, and it's kind of two layers of abstraction. It's kind of it tries to have capture the EVM itself, and which is running on real hardware. So there's the virtualization aspect of it, the opcodes, and there's the aspect which is it then tries to put everything in one dimension. So by that, gas is already kind of a bad metric, and then we have seen the other issue. Still, it's one of the good ones we have, but we have other ones, as we have seen TPS, which has its own problems, state goals, which has its own problems, and so on and so forth. Yeah.
Marc, over to you.
Oh, yeah.
Well, thanks for having me. So yeah, in terms of gas per second, I think it has its limitations really. And that really stems from the fact that not all opcodes are accurately priced. So for example, before Fusaka, we had the ModX precompile, which we could execute around like 20 megagas per second, whereas compared to just standard ETH transfers, which ran around like 500 megagas per second. So what that means is you can ultimately have a block with quite a low gas usage, which still ends up being like a CPU bound. But yeah, that's.
Thank you. Tim.
Thank you. So, but like, what was the question? What was the exact question?
Yeah, so if we're looking at gas today, maybe what are some of the bottlenecks that we're seeing, maybe even in the work that we've been doing?
So, okay. So bottlenecks, I think bottlenecks are just everywhere, just bottlenecks are everywhere. So like one after another, you just have to keep pushing it. Like, I think the biggest like immediate bottleneck is state access, because like it consumes so many IOs. But for some CPU intensive chains like the Worlds, for them I think it's like optimizing the CPU resources, like the cryptographic library, like making cryptographic libraries better is their bottlenecks. So basically, I think it's just bottlenecks are everywhere. It's just solving one and another. Yeah. Some days blobs will probably be another bottleneck. It used to be a few months ago. So just juggling around the bottlenecks. I think that's the bottleneck. Bottlenecks are everywhere.
Yeah, and I think that's something we'll be getting into a little bit later here, hopefully, as well. Mihil, I'll have you go last here. Yeah. Especially at the base team, kind of what are the bottlenecks that you're seeing, whether those are kind of more recent ones or general themes?
Yeah, well, thanks for having me here, first of all. Secondly, I think we are definitely seeing bottlenecks across all the layers. Like, each layer is different, like the different limits for it. Touching on something that Saba said, like, gas is an approximate metric. Even on L1, it's an approximate metric, and I think when you translate that to L2s, I think there's another abstraction over there that we try to make. I don't think gas on L1 and gas pricing on L1, gas pricing on L2 are the same. There's a little difference over there. And right now on the base team, at least, we are seeing more bottlenecks now at the state access level. I think CPU is fine for now. It's like if you like draw bands out, like CPU is okay right now. It's like far out. IO is like much closer. D8 after all the upgrades that recently went through, like things more further out. But like at any given time, these three, or there are more, but like these three are the main ones. We keep hitting them and we have to solve for them. But yeah, that's what I'd say.
So I think we've heard about different bottlenecks that occur based on the different workloads that are happening. Maybe let's go into what kind of some of these specific workloads we should be optimizing for. Like a payments chain is going to look very different than like a trading chain, for example. How do we work together to build some of these workloads that best show these bottlenecks? Wichal, I'll start with you on this one.
Okay, so workloads. So there are kind of two types of benchmarks. One is well, the goal is to have, I would say, fair competition. So it's kind of competitive benchmarks where the goal is that the marketing claims are not as marketing as they want to be, or at least you can interpret them. And there we need kind of these realistic workloads. And obviously, if there are different market players working on different market segments, and if they are only player in their niche, then they have their own single thing. But typically, there are a few application scenarios, and we can derive the workloads for these. And then there is a different type of benchmark where we are kind of searching for the boundaries of performance, also worst case scenarios, and we are a bit doing more the second type sometimes, also because it's kind of the nature of our system that we have to find these boundaries and we have to think of the worst case. And we are focusing a lot on this, but it's important to differentiate between these two. Then again, how we derive one or the other, I pass on to the others. But yep.
Yeah, I think especially thinking about those worst case scenarios matters quite a bit there. I'm going to jump around here maybe a little bit. Tam, do you want to speak maybe to some of the workloads that you've been prioritizing and working on in your benchmarking work?
Yeah, of course. I would. Let me think. I want to take like the world's like chains benchmark that we've done recently. So we've worked on world teams to increase the gas limits, and we vaguely thought that, all right, maybe we can raise the world gas limit to the another blockchain, another OP stack chains that's out there. For example, like, Base or OP mainnets, because like they already raised the gas limit, so like we thought like maybe we can just follow it. But we were wrong, because like we've like ran the same amount of the same block that consumes the same gas. We ran the block that consumes the same gas from the base chain and from the world chain, but the resources consumption was wildly different. Because like the world was like more CPU intensive, and the reason why it was CPU intensive was that world consumes more like ZKP verifying the precompile. And because of that, because like, when the user claims the token, they have to submit the ZKP, and which takes a lot of CPUs. So, so it looked okay. The number was like just, we thought like just, the nominal gas number, maybe we can just increase it, but like it was not. So, it seems like by workload, the chain's throughput can be throughput, and the resource consumption could be wildly different from chain to chain.
Yeah, the research you showed there definitely showed some wild differences compared to other chains. I'll jump around here a bit more, Marc, maybe go over to you on the Nethermind side. How are you thinking about the workloads that you're doing your benchmarking and prioritization work for your company?
Yeah, so I'd say our priority at the moment really is kind of measuring more individual opcodes at the start. And then kind of once we have a better understanding of how we can like reprice these and make them more accurately reflect their actual computational usage, then we have a good model that we can apply like across different kinds of workloads. So I'd say there isn't any specific workload like DeFi or anything which causes a problem, but the kind of main concern is specific worst case scenarios. So like something which is being crafted to take as long as possible. And once we kind of crack this, then that can really help us to like massively scale throughput.
Yeah, I think that definitely makes a lot of sense in your case. I think, Michiel, we'll go over to you, and we can talk about the workloads, but maybe also switch to what are some of these bottlenecks and some of the learnings that we have. So we're benchmarking with workloads in mind based on your chain. Are we being proactive in that today, or are we still in a reactive mode? What are some situations you are seeing arise where you're coming in and solving those with your benchmarking work?
I mean, at least so far, we've been mostly reactive up until this point, and at least at the base team, we are trying to be more proactive and try to address this firsthand. So at base, we have like a few ways we benchmark stuff. We have our own benchmarking tool that we open sourced some time ago that we've using for like benchmarking like particular like opcodes, so like transactions with like one particular opcode is like that's more dominant. We are benchmarking mainnet snapshots themselves. So like if we have like a lot of load at one particular block in some time ago, we are trying to like use that snapshot and use the state from that particular point of time and then benchmark on top of that like our changes. And we also have like our own load testing stuff that we are using in FlashBox Contender. We have our own tool that we're using to spam our test nets and see what breaks. And like after we change like one particular thing on our sequencer or a builder, like what other thing breaks or what's better. So that's like a comprehensive view of how we are benchmarking today at least. And going forward, we want to benchmark more on the new Opcodes and try to be more proactive in that sense. Okay.
So it seems like today kind of what I'm hearing is that like execution isn't the primary bottleneck. It's kind of looking across the entire system. So I think that the part that I want to bring us to next is when one of these bottlenecks is occurring, who's actually feeling the pain on that? What pain are you feeling as a chain? What are your users actually feeling? What's the impact of our scaling limits we have today? Maybe Chab, I'll start with you on this one.
Yeah, so when it's not execution, so when I was starting to look into this quite some time ago now, I was surprised that most of the DevNet testing, testnet testing, benchmarking was going without considering network limitations, basically. So it was kind of almost infinite network resources. So I think we worked a lot on introducing the network limitations into these testings. And I'm working on that. I think I'm also proactive when I have the time. And what was the exact question?
Yeah. So what are kind of some of the
who's feeling?
like who's feeling this pain?
Yeah.
Like the chains, the ecosystem, node operators, users. What does that pain look like?
Yeah. So for networks resources, the pain is definitely on. I mean, it depends on what kind of node operator you are. If you're a home operator, the pain is definitely on the other things that you try to do on your network. It's a compromise there. If you are paying for the bandwidth in a professional setting, then it's there. So definitely that's the kind of consumption amount part. And then when there are limitations, it's important that, so we are publishing things like minimum node requirements, right? You need this bandwidth to run the node. Now the question is, what if you don't have that bandwidth? And we want to make sure that the node is working even under those conditions. Like if no one has the bandwidth in the system, that's clearly a problem. But at least if you for temporarily don't have the bandwidth, we should still make sure that the nodes are working. This is work in progress. I'm pushing for this, but I think currently you would feel the pain a lot because the system, it's just not designed in a way that if you're not hitting the minimum requirements temporarily because your kids are watching TV, then you have issues. Yeah, that's for the network. Then for the other limitations, there is the problem with bottlenecks that it's very much software architecture and hardware architecture dependent, obviously. So it's also trade-offs. Like as bottlenecks are, as we're looking at different bottlenecks, we should reconsider architectural choices and shift the balance between different resources. That's it from my side.
Yeah, go for it, Marc.
I mean, to kind of address the different bottlenecks we see. So, I mean, there's the one that maybe we've mostly touched on, which is around, these worst case scenarios, kind of gas repricing. And there's definitely a lot of untapped potential with execution that we could get from kind of addressing these. So the next thing to tick off would then be state growth. So for example, like the Zen contract is an example of like causing a lot of state growth. And we have an initiative called BloatNet, which we're using to kind of explore the impact of state growth on performance. Yeah, both of these are definitely kind of mitigatable or fixable. And then at some point in the future, I see networking really becoming the kind of primary bottleneck. But in terms of how users kind of feel the pain, I guess it's more like, we have these bottlenecks which prevent us from then increasing throughput. So, users are more likely to see some kind of gas spikes or congestion on the network, right? Yeah.
I think maybe just for the sake of time, Mihail, we'll have you go last on this question here. At the base team, you're really focused on having cheap, fast transactions for your users. When things break down, what does that look like today?
I mean, we had an incident last week, I guess a couple of weeks ago, where we had this kind of a breakdown where a lot of our limit was actually our networking, internal networking. Our mempool nodes were feeling a lot of pressure because we had a burst of transactions with the market downturn. So when that happens, we have dropped transactions. We have a lot of people complaining because of that, or rightly so. So yeah, our immediate fix was scale up our network nodes, and that both and the market stabilizing a little bit, both help regulate our throughput, and it'll fine after that. But this is just highlighting the different scaling limits that we are facing, and it's not just on the execution client or consensus client. It's directly on networking layers or I/O and stuff like that.
Yeah, I think definitely a lot of learnings that come out of that for the future. All right, I think last question here for us. I think we see I think Carl called this out a lot as well. We see a large gap today between the synthetic benchmarking that we do and the real world benchmarking to actually give us the confidence to scale chains as we want to increase the gas limit to enable all users. What needs to be done to close that gap and to get benchmarking as close to reality as possible? Maybe we'll come this way. Mihail, start with you and get one answer from everyone.
Yeah, I mean, we have been, at least at Base Chain, we've been trying to do as many tests as we can beforehand. As we have a phase where we just load tests. We start from our DevNet, then we go to Sepolia, then we go to mainnet. We benchmark our clients on using a benchmarking tool on mainnet nodes. We try different kind of Zen transactions, as what Marc mentioned. Those were a big pain for the base team last year. We try and benchmark against that. So a lot of validation, a lot of monitoring that we do beforehand, before we production. We're confident to roll out of production. There's also talks of having canaries on our test nets, just so those canaries can take something down in Sepolia or maybe not Sepolia but a DevNet, and then we can go out to that. But that's still in the idea stage that in the team right now.
Very cool. Tim?
Well, thank you. Yeah, so I think it's really difficult to synthesize the data. So our approach to scaling the chains was to extract as many as data from the existing nodes data. For example, replaying the blocks of the world, replaying the blocks of the base. We can extract a lot of data from that, and we can extrapolate the gas consumption with that. It's really difficult to synthesize the data because you can't replay the state access because you don't have the user's private key, right? So because you can't, because the random state access is the bottleneck, the biggest bottleneck, but if you can't make it happen, if you can't make it up, then there is no point of doing that. So I think the best way to scale, I think, is just try to extract as many as data from the existing data and scale the chain little by little, little by little by looking at the data. I think so. That's the reason why a BPO is great. Yeah.
So not just triple the gas limit and see what happens.
Yeah.
Okay.
Just little by little. So
Should be fine.
I think the what you guys are doing is great because like you guys try to raise the gas limit like one mega gas limit like every week. I think that's the best approach to raise the gas limit. So,
I guess just to add to that, I think doing it that way, as like me, like when I joined the base team, I'm like, why don't we just double this like tomorrow? And they're like, the amount of incidents we're just gonna have based on that is gonna be crazy. Like every time we have an incident, like there's a lot of people that are affected by it. So we have to be really careful about how we do this, as careful as possible. And we're trying to do our level best in terms of having a better benchmarking suite, better testing suite in general, so we can avoid any degradation of service.
Thank you for sharing that. I think we're pretty much at time here. I'm going to close it out just by saying, I think it's pretty clear that scaling isn't just about hitting high TPS and gigagas numbers. It's really about the workloads, producing these real workloads, solving for these key bottlenecks for our customers in the whole system. One last note, we're doing this benchmarking together. This is a small representation of the group that is dedicated towards this. If you're interested in being involved, please talk to myself, anyone up here, and we'd love to chat. All right, back to Gloria. Thank you. Thank all the panelists for being here as well.